Multi-digit division with partial quotients. Sounds like so much fun. We're going to start with divide multi-digit numbers by 2, 3, 4, and 5. So these should be fairly quick. See? Now, we are using the long division that I was taught as a kid. This is a thing that a lot of folks sort of don't realize when they criticize folks teaching with a more sort of Common Core bent. They're like, oh, there's nothing wrong with the old way, you should just teach that. Well, we do teach that also, because it is, like all other techniques that are used to solve problems, useful in its own way, wherever it is, or blah, blah. It's useful in its own way, and I am not going to say it's bad. So we've got 5 divided by 2,235. Yes, finally, good old-fashioned long division, just like when I was a kid. Let's go ahead and remind ourselves of this process sort of step by step for the first one, and then after that, I'm going to go ahead and start going a little bit more quickly. Okay? So, when doing long division, first thing you do, what can I multiply 5 by to get 2? Well, nothing. Moving on. What can I multiply 5 by to get 22? Aha! Well, I know that 5 times 4 is 20, and now I'm just going to find that remainder. Okay, I'm going to subtract off the 20, and I get a remainder of 2. So 22 divided by 5 is 4, remainder 2. So far, so good. Like I said, long division seems a lot more abstract to me now that I've learned other ways of division. So you might see me getting lost in here. We'll see. The next thing you do is you start working with the next digit. So 5, again, we multiply by 4. Again, we subtract 20, and we get a 3 as the remainder this time around. Bring the next digit down, we get 35, which thankfully is a nice even 5, 10, 15, 20, 25, 30, 35. It's a nice remainderless 7, so our answer is 447 with no remainder. There's your long division. I hope you enjoy it. And it makes sense that the remainder is 0 because, as previously mentioned in my last stream, you can tell that a number is evenly divisible by 5 if it ends with a 0 or a 5. This ends with a 5, so it makes sense that the remainder is 0. Very important that all of your knowledge works together instead of against one another. So if you solve a problem 2 completely different ways, you should still get the same answer, which should highlight the similarities between the 2 different processes. Okay, divide. Well, I happen to know that 120 divided by 5 is 24. How do I know? Because again, I divide by 10, which is 12, then I double to get 24. And then the remainder that's left is 3. Next question. 320, we already know the remainder is going to be 0. Again, it ends with a 0, so it's divisible by 5. Let's see. Dividing by 5, again, I divide by 10. 320 divided by 10 is 32. Then I double it. I get 64. Remainder 0. Oof. This one's kind of gross. 4,454. I can already tell that the remainder is going to be 4, but I'm not going to explain that one. See if you can figure out how I knew that. In the meantime, 4,454. All right, let's see here. 5 goes into 44 8 times. We're going to subtract the 40. We end up with 45. 5 times 9 is 45. So we're left with 0. 5 doesn't go into 4 at all, so that would be a 0. right? We do still put the 0 up there just because the 5 doesn't go into 4. I mean, this is 890, not 89. And as promised, we have a remainder of 4. $6,352 divided by 4. This one's a little bit nice because we can indeed put 4 into 6 once. Our next number that we're shooting for is 23. 4 times 5 is 20. Let's see, which color do I use next? Let's use this one next. 35, let's see. How far down am I on the screen? Okay, not too bad. 35, let's see. 4 times 9 is 36, so this is probably an 8. Running out of space. As always seems to happen when doing long division, I tend to run out of vertical space, annoyingly enough. I happen to know that 4 times 32 is 8, with no remainder. So our answer for this one is 1,588, remainder 0. Two more to go. 416 divided by 3. Now, I feel like I should be able to do this one in my head. I know that 300 and 116. 300 divided by 3 is 100, right? So far, so obvious. The 116 is not divisible by 3. How do I know that that's not evenly divisible by 3? You'd have to go back to my video on divisibility for that, but if you add up the digits, 1 plus 1 plus 6, you get 8, which is not divisible by 3, so 116 is not evenly divisible by 3. But what is? I think I'm going to break this up even further. I'm going to take 116, and I'm going to turn it into 90 and 26. 90 divided by 3 I know is 30. And aha, I know that 24 divided by 3 is 8, with a remainder of 2. So my final answer is 138, remainder 2. So I guess that is how the folks in the previous problems came up with the area models they did. They just sort of said, oh, well, this number I know is divisible by 3, and I can subtract it out and get smaller and smaller numbers until I eventually find something that I recognize. So maybe there is something to this technique after all. Our answer is 138, remainder 2, assuming I didn't screw anything up. I did not. Excellent. Moving on. Last one. 430 divided by 2. We should be able to do this pretty easy, right? 400 divided by 2 is 200. 30 divided by 2 is 15. So we get 215 with a remainder of 0. Not bad. As much as I don't like sitting students down to do a bunch of arithmetic problems like this, the practice can be very useful, especially when expanding these patterns later on down the line.